All right, we are similarly to how we did the exponentials. I'm going to start by making a table for my parent function, log base 2. Remember, this was the inverse of, excuse me, apologize for getting interrupted there by the music, but these are the points on my parent function graph for log base 2. We did this on the front side, again, when we found the inverse for 2 to the x by switching the x and the y's. So we know all of these characteristics already. This is the parent function, so there are no transformations. Our domain is that x is greater than 0. Our range is all real numbers. We have an increasing graph, an x-intercept at 1, 0, and a vertical asymptote at the line x equals 0, which is here, the y-axis. All right, so looking at number 2 here, I have log base 2 of x minus 3. That minus 3 is on the outside, not associated with the x, so that tells me that this is going to be a shift down 3. So I'm going to refer to this table that we used for number 1, and I'm going to subtract 3 from each of my y values. And my x's will stay the same. So here is my new graph. Our domain did not change. X is still values greater than 0. Our range is still all real numbers. We still have an increasing graph. But where is my x-intercept now? An x-intercept is when your y value is 0. So to find my new x-intercept, I'm going to need to take my equation and set it equal to 0. Now this is just a basic log equation. I want to get the log by itself. I will do that by adding 3. And now that the log is alone, I'll rewrite it as an exponential. So my base is 2, my exponent is 3, that's going to be equal to x. Well, 2 to the third is 8. So that means that my x-intercept is going to be at 8, 0. And then our vertical asymptote did not change here. It is still at the y-axis, x equals 0. All right, moving on to 3. I have negative on the outside, negative log of x. This tells me that this transformation is going to be a reflection over the x-axis. So what that's going to do is change the signs of my y's, again referring to that original table from number 1. So all the positives will become negative and vice versa. And then my x values will not change. So here is our transformed graph. Our domain did not change here. X is still all values greater than 0. Our range also did not change. It's still all real numbers. We now have a decreasing graph. My x-intercept is the same, 1, 0, and my vertical asymptote is also still the same. The y-axis, x equals 0. Okay, slight typo on number 4. This should say x plus 2, not x equals 2. So looking at those transformations, the plus 2 on the inside tells me that I'm going to the left 2, and then the plus 1 on the outside tells me that I'm going up 1. So making a table, again referring to my original one, the left 2 means that I'm going to subtract 2 from each of my x values. And then the up 1 tells me that I'm going to add 1 to each of my y values. So here we go. I added 1 too many on that one. That's on me. I was like, that doesn't look right. Okay, that should have been a 3. That was my bad. There we go. Okay, so there is our new graph. Our domain has changed. We have shifted to the left, so I now have x values that are greater than -2. Our range is still all real numbers. This is an increasing graph. My x-intercept did change, but I have it on the table here. It is -1.5, 0. And our vertical asymptote also changed because we shifted. It's now at the vertical line x equals -2. Okay, last two. These are referring to our natural log. So I'm going to graph, or just jot down, sorry, that table for those original values that we used. And so that's going to be about 0.368, -1, 0, 1, 2.7182, or sorry. I did that, and I had this one backwards, sorry. 1, 0, 1, and then 7.3892. Okay, those are the values from our original table for natural log. So that's what I'm going to refer to here. And then looking at this x minus 4 inside the parentheses tells me that I'm shifting this to the right 4. So if I was going to make a new table referencing this one, what I would do is add 4 to each of my x coordinates. And then those y values will stay the same. And I can graph this. All right, so our domain now is all x values greater than 4. Our range is still all real numbers. We have an increasing graph. Our x-intercept did move. It is now at 5, 0. And our vertical asymptote also shifted to the right 4. It's now at x equals 4. All right, last but not least, on number 6 here, again referencing this table at the bottom left corner, the transformations happening here are a reflection in its inside. So that tells me it's going to be over the y-axis, and then that 2 on the outside tells me it's a vertical dilation by a factor of 2. So what this means in reference to my table in the bottom left corner is the sign of all my x's is going to switch. So since these were all positive, they will now become negative. And then the dilation means I'm going to double each of my y's. And now I can graph those. And this graph now has a domain of all x values less than 0. Our range is still all real numbers. This graph is now decreasing. Our x-intercept is now at -1, 0. And our vertical asymptote is still the y-axis, x equals 0. All right, that wraps up our portion of notes on graphing. I will be linking a third and final video for the finding inverses portion of these notes.